Jai Hind children, welcome back to our science class. We are continuing the chapter light. We can start today's class with lens. So, what do you mean by lens? A lens is a piece of transparent glass bound by the two spherical surfaces. Lenses are transparent so that light can pass through lenses. Lenses are of two types, convex lens and concave lens. So, what is a convex lens? It is otherwise known as converging lens or magnifying glass. The convex lens is the lens which is thicker in the middle than at the edges. A beam of parallel rays of light falls on a convex lens from the left side. After passing through the convex lens, the beam of parallel rays of light converges at a point as shown in the figure given below. Hence, a convex lens is a converging lens. Next, about the characteristics of image formed by a convex lens. A convex lens can form real and inverted image. When the object is placed very close to the lens, the image formed is virtual, erect and magnified. When used to see objects magnified, the convex lens is called a magnifying glass. Next is about concave lens or diverging lens. A concave lens is a lens which is thinner in the middle than at the edge. A parallel beam of light falls on a concave lens as shown in the figure. After passing through the concave lens, the rays of light are diverging or spreading out. Now, we can see the characteristics of image formed by a concave lens. A concave lens always forms erect, virtual and smaller image than the object. Let's see the uses of convex lenses. Convex lenses are used as a magnifying glass. In the manufacturing of spectacles, camera, microscope, telescope and binoculars, convex lenses are used. Now, uses of concave lenses. In order to see the image of the person standing outside, concave lenses are used in the peepholes in the door of hotel rooms. Concave lenses are used in making spectacles. All of you know what is sunlight. Is it white or colored? We might have noticed a rainbow which usually appears after the rain. When the sun is low in the sky, an arc of 7 colors seen in the sky is known as the rainbow. The 7 colors of a rainbow are red, orange, yellow, green, blue, indigo and violet. We might also have seen that when we blow soap bubbles, they appear colorful. Similarly, when light is reflecting from the surface of a compact disc, that is CD, we can see many colors. The rainbow is produced by the dispersion of sunlight by tiny drops suspended in the atmosphere. What do you mean by dispersion of light? White light splits into 7 colors when it enters a prism. This phenomenon is called dispersion of light. In the year 1665, Newton discovered by his experiments with glass prisms that white light, like sunlight, consists of a mixture of lights of 7 colors. Newton found that if a beam of white light is passed through a glass prism, then the white light splits to form a band of 7 colors on a white screen. The band of 7 colors formed on a white screen when a beam of white light is passed through a glass prism is known as a spectrum of white light. The 7 colors of the spectrum are red, orange, yellow, green, blue, indigo and violet. Next is about Newton's disk. Newton thought that we should be able to get white light by mixing 7 colors of a rainbow. To prove his point, he made a disk on which 7 colors of the rainbow were painted in equal section. When this disk was rotated, all the colors disappeared and white color appeared. This disk is popularly known as Newton's disk.
Sometimes after the rain, we see rainbow in the sky. It looks spectacular, doesn't it? Do you know how a rainbow is formed? A rainbow is formed due to the phenomenon of dispersion of light. To understand what dispersion of light is, let us perform an activity. For the activity, you need a prism, a white sheet and a cardboard with a small hole at its center. Place the cardboard at a position such that the sunlight falls directly on it. Next, keep the prism such that the light passing through the hole of the cardboard falls on the surface of the prism. At the other end of the prism, fix the white sheet as shown. As the sunlight passes through the prism, you will observe a beautiful band of colors appearing on the white sheet. If you look at these colors of the band from the bottom, they are in the order violet, indigo, blue, green, yellow, orange and red. This sequence of colors can be remembered by the acronym VIBGYOR. The light coming from the sunlight was white light. Are you wondering from where this beautiful band of colors appeared? Actually, the white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange and red, which we saw as the band of colors. When the white light coming from the sunlight falls on the prism, it splits this incident white light into its constituent colors. The splitting occurs because different colors of the sunlight bend through different angles with respect to the incident ray when they pass through the prism. The red light bends the least, while the violet bends the most. Thus, the rays of each color emerge along different paths and become distinctly visible. Thus, we are able to see the beautiful band of colors. This phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light. The band of constituent colors is known as spectrum. This phenomenon was first discovered by Sir Isaac Newton. Now that we have understood what dispersion of light is, let's understand how it causes the formation of a rainbow. A rainbow is generally formed when the sun appears just after it has rained. At this time, many water droplets are present in the air. When the sunlight passes through water droplets in the atmosphere, each water droplet acts like a small prism and refracts the incident sunlight. As soon as the sunlight enters into the prism, that is, the drop, it splits into its constituent 7 colors, VIBGYOR, within the drop. When this band strikes the other edge of the drop, it gets reflected internally towards the first edge of the drop. As the band reaches the first edge, it gets refracted again and finally comes out of the raindrop. This band of colors which finally comes out of the raindrop is what we see as rainbow. A rainbow is always formed in the direction opposite to that of the sun. Thus, the appearance of rainbow in the sky is due to the dispersion of sunlight by the water droplets present in the atmosphere. Dispersion of light not only results in the formation of a rainbow, but we can see this effect in our day-to-day life as well. For example, the beautiful band of colors we observe in water fountains, soap bubbles and CDs are all due to dispersion of light.